Hi everyone. Today we are going to discuss about the deletion implementation part of deletion in double-ended queue. So just again I am discussing. We already discussed the insertion and deletion part in double-ended queue, but before implementation, I just want to review that or revise that deletion part. Here, consider initially the queue is empty. So I am going to insert an element, so 10. So it's updated to, both the values are updated to 0, 0, and again I am inserting the element through rear end, so 20, rear equal to 1. Again insert the element through rear end, 30, 40, rear end 3, then 50, rear end equal to 4. Now I am trying to delete the element 10. So after the deletion, friend equal to 1. Again I am inserting an element, so rear equal to 0, because we are having an empty space here, so I inserted the element at the 0th position. This is the status now. Again I am deleting the element through front end. So after the deletion, friend will be incremented by 1, so 2. Again I am deleting the element, so friend is incremented by 1, 3. Again I am deleting the element, friend is incremented by 1, 4. Again I am deleting the element. So in this case, if I am deleting the element 50, after that what updation we need to make on this friend value, that is important. After the deletion of 50, friend has to be friend is reassigned as 0. So this is the case that we have to consider. So before deletion it was like this, 4. So after the deletion of 50, friend is updated to 0. And again I am trying to delete the element. Here we are having only one element. So after the deletion of this element, friend equal to -1, rear equal to -1. So these are the cases that we are discussing. We have to consider before writing the program. So this is the procedure that I made here. So first step is to verify the queue is empty. How will we verify the queue is empty? If friend equal to -1, then we can send an error message. Printf element is not queue is empty, so deletion is not possible. That is the error message that we are going to produce. Second case, if the queue is not empty, that means else. If the queue is not empty, that what we are going to do is, okay, here I am writing the program for that. If friend equal to -1, print of the error message. I am just mentioning it as error message. Anything that you can fill here. I am not writing the entire thing here. Okay. If the condition is false, that means else. Else I am writing a program like this. If not empty, if it is not empty, then what I told you is we have two cases. First one is if the friend value if a friend represents the element located in the position 4. So I am writing the program for that. If friend equal to max -1, if this is the case, if friend equal to max -1, then max -1, then we have to mention the case accordingly. Before that, anyway you are after confirming that queue is not empty, you can print that element that we are going to delete. Printf deleted element is %d comma a of friend. Okay. Then okay, if this condition is true, then what we have to do is friend equal to 0. Okay. Then again, if this condition is false, else what we are doing is, if friend equal to because we are having only one element in the queue, then we are going to write a program for that. If friend equal to real, then what we are going to do is we are making the value of friend equal to real equal to -1 and that is the case. If again this case also false, then the normal case of deletion, a friend plus plus. Very simple. This is a program for deletion. So verifying whether the queue is, that is the first one, verifying whether the queue is empty. Okay, then printing an error message. If not empty, that means else case. Verify friend equal to max -1, friend equal to max -1. If the condition is true, then making the value of friend to 0. Else, if the condition is not true, that if friend is not equal to max -1, then we are verifying that queue is having only one element. For that we are verifying the condition friend equal to real. That these cases are that we already discussed in the normal case of in the linear queue as well as circular queue, that we discussed the same. If friend equal to real, then friend equal to real equal to -1. There is a slight difference between circular queue and double-ended queue. So these concepts are very simple. Once you if the concept is very clear for you, then it is very simple to write a program for this. If friend equal to real, then friend equal to real equal to -1. Then else, if the condition is again false, then normal case of deletion through friend end, so friend plus plus, that's all. So same kind of operation in rear end. If you are deleting the element at the rear end, verify the queue is empty. If the queue is empty, then error message. If not empty, then what's the next case is okay, I just want to discuss how deletion through rear end. For example, I am having this much of elements here, 20, then 30, then 40, then 50. Friend equal to 0 initially, friend equal to 0, then real equal to 4. Consider this is the case. In this case, I am deleting the element through friend end. So friend equal to 1. Okay, this element is deleted. Again I am deleting the element. In this case we are having only one element, one empty space, so I am trying to insert the element through rear end. So rear equal to 0, 60. Consider this is the case. Okay, so because we are going to discuss the deletion of elements in a circular queue using rear end, so I am discussing the rare cases that for deletion. So the rare cases are discussing here. So friend equal to 1 and rear equal to 0. And now I am going to delete the element at the rear end. So after the deletion of this element 60, where this rear moves to, that is important. After the deletion of 60, the rear value is updated to what? 4. So that is the procedure. So the way, after the deletion of element 60, rear is moved to the 4th position. Okay, so this is a case, and again I am deleting the element through rear end. So this is a deletion case. Rear moves to the next available space. Okay, like this. Again I am deleting the element through rear end. This also deleted. Again I am deleting the element 31. Now I am deleting the element. We are having only one element here. So after this deletion, both the values of friend and rear as -1. So these are the cases that we have to consider before writing a program for a deletion. Okay, first one is verify the queue is empty. So I am copying the program here, because a slight difference that we are going to make on the implementation part using rear end. Friend equal to -1, printf error message. Else, what's the next case? If not empty, verify the rear equal to 0. So if rear equal to 0, so we are mentioning this one here, printf the deleted element, because this is common. Once we are finalizing that the queue is not empty, then we can delete anyhow, whatever it may be, whether it is in the rear end or it is in the front end, then we can confirm that we can delete an element. So here the change that we are making, we have to make is rear end, because we are deleting the element through rear end. So deleted element is a of rear. Then if rear equal to 0, then what we have to do is rear equal to 0, then rear is updated to max -1. We are updating the rear value to maximum size of the array -1. Else, if the condition is false, that is not equal to 0, then verify the queue is having only one element. So how will we verify if rear equal to? Okay, this is a case. So I am copying the same here and pasting it here. Okay, if rear equal to 0, then what we are doing is friend equal to rear equal to -1. If this condition is false, that means it is not. If we are having multiple elements, that means more than one element, then what we have to do is rear minus. Very simple. Program is over. So these are the cases of deletion. Clear? So double-ended deletion part in double-ended queue, the implementation of deletion part in double-ended queue is over. Okay. Next, we are going to discuss about linear search. Linear search in array. Linear search in array. That is the next important topic in our data structure. Linear search and binary search. So very simple. It is not related to queue. It is a separate part. So I am using the array here. I am copying the value. Because it's very simple. Linear search is very simple. Okay. So we are discussing about linear linear search. Okay. Here we are having an array with 5 empty spaces, 0 to 4. Consider I am having this much of elements in the array: 20, 50, 40, and 5. These are the elements that we have. What do you mean by linear search? Is I am going to search the element linearly. For example, I want to search the element 50. So first step is to verify 50 equal to 10. Okay, if 50 equal to 10, then 50 equal to 10. Verifying this condition is true. If the condition is true, then we can say that the element is available. In this case the condition is false. So 50 not equal to 50 is the element that we are going to search from the array. So 50 equal to 10, the condition is false. Then moving to the next position, 50 equal to 20. Again this condition is false. That means Q is element is not available in the array. Again I am moving to the next position, 2. So 50 equal to 50, this condition is true. If the condition is true, then we can say that the element is available in the array. So that is a linear search. So linearly we are checking whether the element is available in the array. For example, I am going to verify whether the element 5 is available in the array. The step is first verifying whether the element is available in A of 0. What is A of 0? A of 0, 10. 5 equal to 10, condition false. Then next step is to verify 5 equal to A of 1. That is 5 equal to 20, condition false. Then 5 equal to A of 2. A of 2 is 50. 5 equal to 50, condition false. Then A of 3, 5 equal to 40, condition false. Then A of 4, 5 equal to 5, condition true. Then we can say that the array is having the element 5. Okay. For example, 15, I am trying to search the element 15. So again starting from 0. So 15 equal to 10, condition false. Then 15 equal to 20, condition false. Then 15 equal to 50, condition false. 15 equal to 40, condition false. Then 15 equal to 4, that means 5, condition false. What's the meaning of this is 15 is not available in the array. That is a linear search. Here we are continuously verifying one by one 10 because this is a procedure, linear search. We are continuously verifying the elements in a sequential order. First verifying the 0th element, then the first element, then the second element, then the third element, then the fourth element. So this is a linear search. Okay. So today I am closing this video session. Next class we are going to discuss about the binary search. Okay. Thank you.